Uh, Ace Rothstein, played by uh, uh, Robert De Niro, based off of, I think his name was Frank Rosenthal, actually. It's based on a real person. But he was complaining about 3 wins on the slot machine within 20 minutes. But let's say that hypothetically, he was complaining about 3 wins in 3 attempts. Well, even 2 wins in 2 attempts would be very unlikely, because let's say that Ace Rothstein is correct. Let's say the Robert De Niro character is correct. What's the probability that in 2 attempts you get 2 wins, 2 big wins, the grand prize, if the probability of a grand prize win on a single shot or a single pull of the slot machine is literally 1 in 1 million, right? Well, it's the probability of a win on the first shot times the probability of a win on the second shot. That assumes what I word? That assumes independence. That assumes independence. Now, if the machine's fixed or rigged, then we don't have independence, right? But assuming independence, the probability would be the probability of a big win on the first pull times the probability of a big win on the second pull. Now, if Ace is right, and let's say the probability of a win on a pull is 1 in 1 million, 1/1 millionth. So the probability is 1/1 millionth times 1/1 millionth, or 1/1 millionth squared, right? 1/1 millionth squared, which is 1 in 1 trillion. So the probability of getting 2 big wins in 2 attempts would be 1 in 1 trillion. And for 3 wins in 3 attempts, it would be 1/1 millionth times that. It would be even more ridiculous. So that's what Ace Rothstein was getting at. So last time we were talking about probabilities of and problems and events, right? Compound events with and in them. And we tended to multiply probabilities then, all right? Now, related to that was the idea of and situations where we had conditional probabilities, right? So remember the probability of B given A. All right, we talk about conditional probabilities. In particular, the multiplication rule said that the probability of A and B happening was the probability of A happening times the probability of B happening, given that A has already happened. That was the idea. And I want to discuss a related problem with you. And this is called the birthday problem.